This is the image they said the defense establishment would never have to explain. A $2 million Patriot interceptor missile, the crown jewel of American air defense technology. The system sold to 40 allied nations as the gold standard of protection against ballistic threats, streaking upward into a night sky over Saudi Arabia to destroy an incoming drone that was assembled in a Houthi workshop in Yemen for approximately $2,000. The intercept succeeded. The asset was protected, and the United States military establishment quietly recorded a cost exchange ratio of 1,000 to 1 against an adversary with no Air Force, no Navy, no satellite network, and no defense budget worth measuring. That ratio, $2 million spent to defeat a $2,000 threat, is not a footnote in an obscure military journal. It is the central fact of modern warfare, the number that is quietly terrifying every defense planner in every NATO capital, and the financial logic that is breaking the most expensive military architecture ever assembled by human civilization. It is Tuesday, April 8th, 2026, and for the first time since the nuclear arms race inverted the economics of global security in the 1950s, the defenders are losing the cost equation. The attackers have found something cheaper, more scalable, and more democratically accessible than anything the 100-year history of industrial warfare produced. And no one, not Raytheon, not Lockheed Martin, not the Pentagon, not the combined research budgets of the NATO alliance, has a fielded solution. Buckle up, because what follows is the full technical, financial, and strategic explanation of why the cheap weapon is winning, how it works, what it costs, and what happens to the world if the people currently building these systems decide to point them somewhere other than a desert battlefield. Here is what you need to understand before anything else. This is not a new problem. The history of warfare is at its core a history of cost asymmetry, of one side finding a method of violence that is dramatically cheaper than the method required to defeat it. The English longbow at Agincourt in 1415 allowed a relatively small English force to defeat a far larger and more expensively equipped French cavalry. Because the cost of training an archer and producing 1,000 arrows was a fraction of the cost of equipping, training, and fielding a mounted knight, the IED, the improvised explosive device, killed more American soldiers in Iraq and Afghanistan than any other weapon system, at an average construction cost of approximately $30, against a military response that eventually consumed $60 billion in counter-IED programs and produced an armored vehicle fleet that cost $47 billion to FARC. Field history teaches us consistently that the expensive side of an asymmetric cost equation eventually faces a reckoning. What is different today? What makes the current situation genuinely unprecedented in the history of cost exchange warfare? Is the speed of the capability curve, the breadth of the technology's accessibility, and the sheer scale of the financial gap between attack cost and defense cost. The gap is not closing. According to defense economists at the Center for Strategic and Budgetary Assessments, based on current procurement trends, the cost exchange ratio in drone warfare is widening by approximately 40% per year. The cheap side is getting cheaper faster than the expensive side is getting more effective. Let's get precise about what we are actually talking about, because the mainstream media coverage of this phenomenon has been frustratingly vague in its technical specificity. The cheap weapon is not a single technology. It is a family of converging technologies built on the same foundational economics and understanding that family. Individual electronic components, many of which require specialized semiconductor fabrication, advanced composite materials, and manufacturing tolerances measured in microns. The Raytheon production facility in Andover, Massachusetts, can produce approximately 550 PAC-3 missiles per year at full capacity. That is the current maximum output of the most capable missile defense production facility in the world. Ukraine alone is firing approximately 300 Patriot interceptors per year, defending against Russian cruise missile attacks. Saudi Arabia is consuming a comparable number. Taiwan's Patriot batteries sit on alert against Chinese ballistic missile scenarios. Israel's Iron Dome and David Sling systems, philosophically similar in their cost exchange problem, are consuming interceptors at rates that have required 3 emergency resupply operations from U.S. stockpiles since October 2023. The combined interceptor demand across all theaters where American-supplied air defense systems are operational is currently exceeding production capacity by an estimated 35%, according to a Government Accountability Office assessment leaked to defense media in December 2025. The factory cannot keep up, and the factory cannot be made to keep up in any economically rational time frame because building a second Patriot interceptor production line requires a capital investment of approximately $2.4 billion in a construction timeline of 4 to 6 years, by which point the drone technology will have evolved through at least 3 more generations. Nobody in the mainstream media is talking about the semiconductor dependency that makes this crisis fundamentally different from any previous defense production shortage. Here is the structural reality. The advanced guidance systems, proximity fuzzes, and target discrimination sensors in modern interceptor missiles require 3rd and 4th generation semiconductor chips manufactured on process nodes of 7 nanometers or smaller. There are currently 5 fabrication facilities in the world capable of producing chips at this specification: TSMC in Taiwan, Samsung in South Korea, and 3 Intel facilities in the United States. The global semiconductor supply chain was already under strain from commercial demand before the defense production crisis began accelerating in 2023. The National Defense Industrial Association published an assessment in January 2026 noting that defense-specific semiconductor orders were experiencing lead times of 52 to 78 weeks, meaning that a component ordered today to support missile production would not arrive at the assembly line for over a year. Meanwhile, the FPV combat drone that constitutes the primary cheap weapon threat uses commodity microcontrollers manufactured on 28-nanometer process nodes, a mature, abundant, globally distributed technology produced by dozens of manufacturers across multiple countries, with lead times measured in days and per-unit costs measured in dollars. The asymmetry is not merely in the weapons themselves. It is baked into the entire industrial supply chain that supports them. One side is dependent on the most constrained, geographically concentrated, and strategically fragile manufacturing ecosystem in the global economy. The other side is dependent on the most abundant, distributed, and economically resilient one. Let's examine the specific operational scenario that has defense planners most concerned, because the abstract economics only become truly alarming when you map them onto an actual military conflict. The scenario is the Taiwan Strait, and the analysis here is based on publicly available wargaming results published by the Center for Strategic and International Studies and the RAND Corporation, supplemented by what sources describe as the general thrust of classified operational assessments circulating within Pacific Command. China's People's Liberation Army has been observed through commercially available satellite imagery, pre-positioning drone manufacturing and logistics infrastructure on coastal Fujian province bases directly facing Taiwan. The current PLA doctrine, as described by analysts with access to Chinese military publications, envisions using mass drone swarm attacks as a saturation layer against Taiwan's Patriot and Skybow air defense batteries, at the outset of any invasion scenario. The operational logic is precise and devastating in its simplicity. Taiwan's Patriot batteries carry a finite interceptor magazine, approximately 240 PAC-3 missiles in total inventory across all deployed units, representing a magazine value of roughly $960 million. The PLA launches a wave of 500 low-cost loitering munitions, shade equivalents, costing approximately $10 million total, minus against Taiwan's radar and command nodes simultaneously. Taiwan's Patriot batteries engage. The magazine depletes. The PLA launches its conventional ballistic and cruise missile strike against airfields, naval bases, and command infrastructure into essentially uncontested airspace. Every American war game that has modeled this scenario, according to sources familiar with the classified results, produces the same outcome. Taiwan's integrated air defense system is magazine exhausted within the first 90 minutes. The cheap weapon did not destroy the billion-dollar defense system by being more powerful. It destroyed it by being more numerous. The psychological and institutional dimension of this crisis is perhaps the most consequential and the least discussed. Here is what the data shows about how the defense establishment is responding internally. Sources inside the Office of the Secretary of Defense describe a pattern that organizational psychologists would recognize as cognitive dissonance at an institutional scale. The procurement system, the budget cycle, the contractor relationships, the congressional appropriations process, the career incentive structures of senior military officers. Every institutional mechanism that governs American defense investment was built around the logic of the expensive, sophisticated, precision-guided weapons system, the F-35 program, $1.7 trillion total lifecycle cost. The Gerald R. Ford-class aircraft carrier, $13 billion per hull. The B-21 Raider strategic bomber, $692 million per aircraft. These programs represent not merely defense investments, but the organizational identities of the services, the economic foundations of congressional districts across 32 states, and the professional legacies of the generals and admirals who champion them. Acknowledging that a $400 drone represents a genuine strategic threat to these investments is not merely a technical assessment, it is an institutional heresy, and sources say the resistance to that acknowledgement within the senior defense establishment is fierce, structural, and given the procurement timelines involved, potentially catastrophic in its consequences. The international proliferation dimension is the variable that transforms us from a military problem into a civilizational one. Here is the current threat landscape, as described by sources familiar with the most recent intelligence community assessment of drone technology proliferation, which was reportedly updated in March 2026. Iran is producing approximately 35,000 combat drones per month, with significant technical assistance from North Korean electronics manufacturers. Russia has transferred drone manufacturing technology and technical personnel to Venezuela, Cuba, and Nicaragua. China's commercial drone manufacturing sector, centered in Shenzhen and producing primarily for civilian markets, represents a dual-use production base of 80 million drone components per year that cannot be meaningfully interdicted through export controls. The Houthi drone program that has been striking Saudi and commercial shipping targets since 2019 was built on $40 million in Iranian investment and a technology transfer that took approximately 18 months. That same template, $40 million, 18 months, is now available to every non-state actor, every regional militia, every narco-trafficking organization, and every domestic extremist group with sufficient motivation and organizational capacity. The technology diffusion is not a future risk. It is a current reality, and the gap between military-grade drone swarm capability and commercially available consumer drone technology is narrowing at a rate that, according to sources inside the DHS Science and Technology Directorate, will effectively disappear within 36 months. Worst case scenario, the magazine dev crisis goes critical in a two-theater simultaneous conflict. The United States is committed by treaty and strategic interest to the defense of Taiwan, South Korea, Japan, and the NATO alliance simultaneously. The current American interceptor missile inventory across all systems and all theaters represents a total magazine value of approximately $22 billion. Sound like a large number? Here's the context. At the consumption rates observed in the Ukraine conflict, that inventory would sustain approximately 14 months of active air defense operations in a single high-intensity theater, in a two-theater scenario, Taiwan Strait and Korean Peninsula simultaneously, which is the exact contingency the national security strategy describes as the pacing threat that inventory sustains. Approximately 7 months of operations before the United States faces a choice that no American president has ever confronted: prioritize one ally's air defense over another's, or deplete the interceptor magazine entirely and defend the homeland with an air defense system that has been drawn down to levels not seen since the early Cold War. The cheap weapon does not have to win a single engagement to break the American security architecture. It only has to be produced faster than the expensive weapon can be restocked, and based on current production rates. On both sides of that equation, it already is. The historical weight of this moment demands that we look past the immediate tactical and financial crisis to the deeper structural transformation it represents. Every technology that has broken the cost exchange logic of a previous military era has also broken the political order that rested on that logic. The machine gun broke the offensive dominance of cavalry and produced the political conditions that made the mass conscript armies of the First World War necessary, armies so large and so costly that their mobilization made the war politically impossible to stop once it started. The atomic bomb broke the cost logic of conventional force projection and produced the deterrence architecture of the Cold War, a system of enforced stability resting on the mutual assurance of annihilation. The drone swarm is breaking the cost logic of precision-guided conventional warfare. And the political order it is breaking is the one that has governed security relationships since 1945. the order in which American industrial and technological superiority underwrite the security commitments that hold the alliance system. Together, that keep the sea lanes open, that sustain the dollar's status as the world's reserve currency, and that have prevented a major power war for 80 years. When the cheap weapon becomes ubiquitous and based on every technology diffusion curve available, it will be ubiquitous within a decade. The credibility of the security guarantees that rest on expensive weapons supremacy will be in fundamental question, not because the United States loses a war, but because the cost of maintaining the current security architecture will exceed the economic capacity of the Democratic Alliance to sustain it. The founders of the American Republic understood something that the current defense procurement system has apparently forgotten, that the sustainability of a security system depends not merely on its technical capability, but on its economic proportionality to the threats it addresses. George Washington's warning about the dangers of permanent military establishment was not pacifism, it was fiscal prudence, the recognition that a security architecture that consumes the republic's economic vitality and its own maintenance ultimately destroys the thing it was built to protect. The current trajectory of the cost exchange crisis and drone warfare is not a problem that more defense spending solves. It is a problem that requires a fundamental reconceptualization of how military power is built, what it is designed to defeat, and what it genuinely costs to sustain a security architecture in an era when the barrier to military-scale violence has dropped below the economic threshold of the individual actor. That reconceptualization is not happening at the pace the threat demands. The procurement system is still buying $692 million bombers. The congressional authorization process is still organized around legacy platform programs. The senior leadership is still fighting the last war, and the $400 drone is already winning the next one. Watch the quarterly earnings calls from Raytheon and Lockheed Martin over the next 6 months. Specifically, watch the production rate guidance for interceptor missiles, which will tell you whether the industrial mobilization required to address the magazine depth crisis is actually beginning. Watch for the next major Houthi drone strike against commercial shipping in the Red Sea, because every successful attack on a vessel worth $200 million by a weapon that costs $20,000 is a data point that the reinsurance market is already pricing into maritime premiums. Watch the Pentagon's budget request for fiscal year 2027, specifically the line items for directed energy counter-drone programs, the high-powered microwave and laser systems that represent the only theoretically cost-competitive answer to the swarm threat, and watch whether those line items reflect genuine prioritization or are still being crowded out by the legacy procurement programs. And watch, most importantly, the open source reporting from the front lines in Ukraine, where the next generation of the cheap weapon is being battle tested right now in real conditions against real defenses, producing real data that every military on Earth is analyzing with a level of attention that the official briefings will not reflect for another 18 months. The cheap weapon is not coming. It is here. The billion-dollar defense systems are already being destroyed. The only question still open is whether the institutions responsible for American security will adapt before the cost exchange crisis becomes a strategic catastrophe, or after. Subscribe, because that question is going to be answered on a timeline that will not wait for anyone's convenience.